Good morning, everyone. So today we would like to discuss about Java, the introduction to Java. Anyhow, we have discussed in the last two classes about what is object-oriented programming, what are its features. So topics which we have covered earlier will be useful and will be repeated now and then as we go along while learning Java. So let me start now. I hope my screen is visible to you as well as I'm audible to you. Just confirm.
Yes, sir. Clear, sir. Good.
Okay, fine. Okay. Now, again, we are going to learn another language that is Java. So, it is an object-oriented programming language. So, already we have learned C earlier. C is an structural-oriented programming language, whereas Java is an object-oriented programming language. So why this Java came into existence? What is its importance? Why the object-oriented programming has a greater importance? Because in the procedural language, what happens here is as the size of the code increases, it is very difficult to handle. Okay, because once the code processes 10,000 odd lines, what happens is it is very difficult to handle. As I just mentioned yesterday that if you are declaring variables as global, the data is free flow. Anyone who is capable of accessing the global variables can change the data, can access the data. So that shouldn't be the case. So this object-oriented programming came into existence, and also why Java has came into existence very soon. We are going to learn. Okay. So next, what is this Java? Java here is it is actually conceived by James Gosling, Patrick Norton, Chris Worth, Ed Frank, and Mike Sharding at Sun Microsystems in 1991. Then long back in 1991, so these five people, James Gosling, Patrick Norton, Chris Worth, Ed Frank, and Mike Sheridan, has conceived Java. So previously it is means at Sun Microsystems 1991. So for your information, right now Sun Microsystem is owned by Oracle. So Java comes from the Oracle Corporation right now. But when it started, when it was conceived in 1991, it belongs to Sun Microsystem. So initially, Java was called as an oak because named after the oak tree. Because while they are working, they used to have an oak tree there. Just they named it as an oak tree. But later on, it is named as Java in 1995. Uh, and it is related to C++, which is a direct descendant of C. So Java is mostly related to C++, which is a direct descendant of C. So a question may arise that because you people are not much aware of C++, can we learn Java? Yes, why not? You can learn Java without any problem, though you are not much aware of C++. But the thing here is when you are supposed to learn Java, compulsorily you must have an awareness of C language because of the C structure. Because the structure of Java programming is similar to C language. Okay, so some of the features of C++ are taken into this Java language. So obviously, people you must have an idea about C. I hope everyone is having an idea about C. Okay, so if someone says that we are not aware of C, then I can assure I have an assurance that because I have taught C, everybody is having a little knowledge. Okay, so now from C, what Java has taken? So Java has taken its syntax. So from C language, the Java has taken its syntax. So you know that we start with main function. Java is also having a main function. Okay. So likewise, the code is enclosed in the braces. Then every line is terminated with a semicolon. Okay. Okay, like the features, the syntax of C is used by Java. And many Java's OOP features, the object-oriented programming features, were influenced by C++. So the next point here is what is the object-oriented programming is a programming methodology that helps to organize programs through use of inheritance, encapsulation, and polymorphism. So when you are using object-oriented programming, programs are organized using the concept of inheritance, encapsulation, polymorphism. What is the encapsulation, inheritance, and polymorphism? In the previous class, we had discussed in detail. Of course, how they are implemented and how they are used, we will be learning in the coming classes. Then, what is the primary motivation of development of Java? So, because they want a platform-independent language. They want a platform-independent language that could be used to create a software that is embedded in various consumer electronic devices such as micro ovens and remote control. So they want some language which is influenced, which can be fit into this consumer electronic devices as well as micro ovens and remote controls. That's the reason why the Java has came into existence. So what is this architectural neutral? What is this platform independent? So let me explain you this point very clearly about what is this platform independency is it? Because already you have learned in computer organization previously in this first semester in CO, you might have learned this what instruction set architecture. Sir might have spoken about the instruction set architecture. So there are please try to understand this concept very clearly that mm, mm, uh, there is an instruction set architecture for every processor. So I might have discussed about the 8085 instruction set architecture. You have a chapter in, you have a third chapter, I hope so, that is instruction set architecture in your syllabus, where the sir has discussed about the various instructions, the 8085 microprocessor instructions with you. So if no, okay. So what does it mean here is every processor will be having an instruction set. So whatever the program which is written, so it is going to convert into its own language, instruction set architecture, and it is going to execute that program. Okay, and now one machine has a different architecture. Means one compiler or one processor may have different architecture compared to another family of processors. So I just give you an example. Just wait. Assume assume that you have three processors A, B, and C. Three processors which are A, B, C. Three processors we have. Okay, so processor A and B belongs to same family. Processor A and B belongs to same family, and processor C is from different. Means what is the same family in the sense? For example, A and B belongs to this Intel microprocessor 8085 and 8086. Consume that like that 8084 and 8084 microprocessor. Then what happens here is any program which is written on machine A can be easily can be executed on machine B. Means a program which is written on microprocessor A can be executed on microprocessor B because they both belongs to same family. Why they belongs to same family? Because they are from same make, so they follow the same instruction set architecture. Okay. Likewise, if I want to work out with the same program on some other machine, now in machine C, because it is from different family, it is from different make. For example, it is an AMD processor. That at that reason, at that time, what happens here is you need to rewrite the program according to its own instruction set architecture. You need to write an own instruction set architecture. So that is a problem. Okay. Now, what another point here is, because you are having different high level languages. So in the later stages, what happened? We used to write the programs in high level languages, and they are being converted into low level languages either using the interpreters or compilers. So if I talk about the compilers here, what the compiler is doing, it is converting the source code into machine code or object code. So for instance, here I have a diagram to show you that when a C program is compiled, it is converted into object code, the native code of the machine. Okay, according to the machine's native code, the program is going to be converted into object code, then to executable code. Okay, so now what is the problem here is if one compiler is written, the compiler is going to convert the source program into the local native code. If the same native means, if another machine is there of different make, what happens here is, again you have to rebuild another compiler which should convert this source program into native code. Okay, so for different types of machines, different types of makes, we need to have different types of compilers here. So means if there are some 100 different machines there, 100 different types of compilers you have to return, and 100 times you need to compile the program, and then you can execute. So that is the problem here. So to overcome this, they have designed a Java where it is architectural neutral. Architectural neutral in the sense the platform independent. So irrespective of any platform, you are going to write the program, and then you are going to compile the program once it is compiled, so it can be run on any machine provided on some specific conditions. Okay, so mainly it is targeted with consumer electronics, because at that time 1991 or 1990s, what happens is the usage of this consumer electronic devices have been increased, such as micro ovens, remote controls, washing machines, or any other devices here. So because of that, what happens here is they prefer to have an architectural neutral or architecture platform independent language. That's the reason why Java has came into existence. Okay. At the same time, what happens here is the usage of internet, the World Wide Web has been emerged. So because of the means this worldwide emergence of World Wide Web, so it is demanded a portable programming language. So a language which is a platform independent, a language where we can write a program and you can run it on any machine. Then Java has become more and more popular. Java has become more and how it has become more and more popular. We will discuss more about this later on. But I hope you got an idea about what I was telling. So, any doubt regarding this particular topic?
No, sir.
So, if anyone still can wants some clarity, then I will try to explain in some other better way. Okay. So now in the end, you can again ask me if you have any doubt. Okay. Now the next point here is Java expands the universe of objects that can move about freely in the cyberspace. So it has an objects which can be moved, means non-tangible objects which can be used in the cyberspace, in this internet, move freely from one place to another place. So that is another advantage of Java. Then using Java, actually we are supposed to create two types of application, two types of programs. You can write the two types of programs. One is applications and another is applets. So in our syllabus, we are having both these application programs as well as the applets here. This application programs that run on a computer under an operating system of that computer, it is of two types. So any program which is written in Java, it is going to run on it's under the operating system where the Java has been installed, and then it is of again two types. One is a console-based application, and then it's a Windows-based application. So console-based application in the sense the applications which are run from the console, so from the command prompt. So this is completely a character mode interface where only the characters. So you're supposed to give the commands using the characters, and then the program will get executed, and you are going to get the result. So then we have the window-based applications using frames. I mean, the standalone window-based programs can be developed, and then they can be run, provided, of course, they too require JVM. What is JVM? I will tell you, the Java Virtual Machine. Okay, then you have an applet programming where the applet, these are the small tiny programs. It can be transmitted over the internet and executed by a Java compatible web browser. So if any web browser is there, means if you want to run a program in a web browser, then the Java compatible means the applet can be used. So these are the two types of programs. Next, if you observe this diagram, Venn diagram here, what is the comparison? What is the comparison between relationship between the C, C++, and Java? See, most of the part here is actually taken by Java. Means the C syntax, some of the object-oriented features of C++ have been taken by Java, and Java has its own new features. Okay, because you are somewhat aware of C, okay, you need not worry about the C++. Those things will be covered in the our syllabus clearly without any problem. So this is what is the relationship. Most of the syntaxes, because C is a subset of C++, and Java contains syntax of C but does not support pointers, etc. of C. So that is a good news for you. There are no pointers in Java. Okay, so no pointers in Java. You need not worry about this creating pointers and joining them. Those all things. So those can be avoided. Next, you have Java's object-oriented features are influenced by C++. So most of the features of Java, C++ are most of the features of C++ are acquired by the Java. But it doesn't support some of the features which are already there in C++, like operator overloading, default function arguments, templates, friend functions, etc. So there is a concept called templates in Java, C++, which is not included in Java. Likewise, you don't have an operator overloading concept also. What is operator overloading? In the sense where you are going to add, overload change the meaning of the operators. So means, of course, not meaning of the operators, but they can be used in different sense. So if suppose plus is an operator, okay. So where A and B, you can say A and B, C are variables now. A and C are variables. But in fact, A and C, in case of C++, you can add two objects. Can add two objects. The meaning of that is when you are adding two objects, the contents of two objects are being added there. Okay, so this is actually can be done in C++, but of course it is not included in Java. Another point here is about it doesn't support the default arguments. Default arguments you can understand very clearly. So say for example, there is a function called add of some int A, comma int B, comma int C. Okay, so then you have the piece of code here which is written. Okay, piece of code which is written. Then when you make a function call, I should call it as add of some 2, 3, 4. Then what happens? 2 is stored in A, 3 is stored in B, and C, and 4 is stored in C. So this is actually happens in case of C. Of course, it is in C here. What you can do in C++ here is you can have the default arguments for this. Default arguments. So A is equals to 1, B is equals to 1, and C is equals to 1. In this case, what happens here is when you are passing add of 2 comma 3 comma 4, a is stored with 2, b is stored with 3, and c is stored with 4. Now if suppose if you are not passing C there, then C automatically by default is taken as 1, and A with 2, B with 3, and C with 1. So 2 plus 3 plus 1 is done. Previously, when I'm passing all the three values, 2 plus 3 plus 4 is done in the code. Okay, inside the add function. So if suppose I'm not passing this, okay, then 2 plus 3 plus 1 is done. So if suppose I'm not passing 3 also, then A is taken as 2, B as 1, and C as 1, then 2 plus 1 is done. And if suppose I'm not passing anything there, then A is taken as 1, B is taken as 1, C is taken as 1, and 1 plus 1 is done. This all happens in C++. This can be done in C++. Now, what Java says here is the concept of default arguments is been removed in Java. So there is no concept of default arguments in Java. So compulsorily, if there is a function which is expecting 3 arguments, then you need to pass all the 3 arguments. Okay, so that's what is about the default arguments concept, which is there in C++, and it is removed in Java. Okay, next. Yes, so you have different editions of Java. One is standard edition, Java standard edition, which is the core part of the language. It supports the development of applets and applications. Uh, uh, it supports the concept of applets and applications, but doesn't support the web applications and enterprise application development. So standard, and in our syllabus, mostly we are going to learn this core part language. Then you have J2EE, Enterprise Edition, so which is used for developing the enterprise application development, which is meant for the enterprise application development. Provide servlets, JSPs, uh, provides servlets, JSPs, EJVs, means the Java uh, Java Java server pages, enterprise Java beans, Java mail services, Java mail services. Those can be used. Those can be developed here. So web-based applications and enterprise applications can be developed using J2EE. Then you have the micro edition, which is used for micro devices. Okay. So we have the JDK, Java development standard JDK development kit here. It is a software development kit for application development. So it contains command line compiler of Java. So you have a compiler here, the command line compiler, where you can compile your program. You have a JVM, Java virtual machine. What is the importance of JVM? I will tell you very soon. Then you have some sample programs and other tools also. It supports the development of applications as well as applets. So some of the tools are Java C. To compile the program, you are going to use Java C. Java is to launch the Java applications. You have an applet viewer, means to run a program, you need to have a command called Java. Java C is to compile the programs. Then you have an applet viewer, which is used to run the applet without a browser. Then you have a JDB, the Java debugger, and to create a Java archive files, you have a jar command. Okay, so these when practically we use, we can understand those here. Next, the features of Java. Next important concept to discuss here is about the features of Java. Now, what features the Java is having? Java is a very robust language, means robust in the sense very strict. So Java is a strictly typed language. So it doesn't allow the elements outside the boundary of an array. It is not allowing us to access any element which is outside the boundary of an array. Okay, strictly typed in the sense you need to be very strict while typing the language. So you need to follow the syntax very strictly and properly. The naming is also should be the names which you are using. So it is very case sensitive. You should be very careful while typing the Java program. Like for example, you have a class name called array. Okay, uh, index. Sorry, index out of bounds exception. This is the name of a class actually. Okay, so here when I type this without spaces, I have to type in this fashion only. A capital, then I capital, then O capital, then O capital, B capital, and E capital. So I have to type it like this. So if I miss out anything like this, so it may show you an error. So it may show, it may raise an exception on an error here. So which you need to correct. So it is not going to accept even a single mistake in the while typing. Then the second point which is mentioned here is doesn't allow to access the elements outside the boundary of an array. So what is that? What is that meaning here? So for example, in case of C, when I declare an array like this int a of 10, so I can have an elements from a of 0 to a of 9 in C program. Now, if suppose in your program, if you try to access a of 10 in C, I'm talking about C then program will run, program will get compiled, it will run. Of course, it is going to show a garbage value, an irrelevant value, which is not within the boundary of an array there. Means if you are trying to access a of 10 also in C program, it is going to work out, but what value you are going to get, that we cannot predict. So it may be some other value, something else here. But whereas in case of Java, if any array is declared like this in a of 10, then strictly a of 0 to a of 9, you can access the elements only from a of 0 to a of 9. And if you are trying to access an element a of 10 in case of Java, then the program doesn't get compiled. It is going to show an error. It is going to raise an exception then. Okay, so that's the reason why it does not allow to access any elements outside the boundary of an array. So whatever is the boundary of an array, it is going to it will allow the programmer only access only those elements. Then you have makes the exception handling mandatory. So if any type of exception is there, then that exception should be handled by the programmer. So it's a mandatory here. So in the sense, what is that? To give you an example, that for example, if you are opening a file, so in case of C, for example, I will just show you a comparison. Let me open the file and I will show you. Now here we already discussed this program. Okay, so you're trying to open a file in case of in C. Here you have created a file pointer fp. Then you are trying to open a file called abc.txt in write mode. Now, first suppose this file is not existing. Then it is going to return a null, and you are printing a value that unable to create a file. I mean, you are just handling this. Means you are telling the compiler that what it should do when it is unable to create a file. Right. Likewise, if I show you another program here, just wait. Yeah, here, see here. Here you can see the code. Fopen is equal fopen num.txt in W plus mode. Now here I have not written that piece of code. Previously, I told you, I told the compiler that what it should do when it is unable to open the file. I just written that code piece of code also, that what it should do when it is unable to open the file. At the same time, in this program, I have not written this. I have not written this. Okay, so in both ways it works. Whether you're writing, whether you're not writing, in case of C language, it will work. So if suppose if it is unable to open the file, then it is going to show an error. At the execution time, it is going to show an error. Okay, so but some garbage values or something else, it is going to show an error while running the program in case of C language. Now, while coming to Java, now this is mandatory. Means you have to tell as a programmer, you must have to write this. You must have to write this in the sense of what it should do. Means what is, first of all, what is an exception here? Exception is an abnormal situation. Exception is an abnormal situation. It may not be an error. It is an abnormal situation here where some abnormality has happened, something unusual has happened. Then you should handle such situation. You should handle such situation. Though you have to tell what it should do when some unusual situation has happened. How it has to react. Okay, so such an exception, like another practical example, I will tell you. See, while making a call, sometimes you say number busy, or customer is out of coverage area. Now, such messages which you are getting while dialing, these are abnormal situations. Normally, they doesn't happen. So sometimes if there is no signal, sometimes you are talking to someone else. You will come across with such situations. So what the programmers have done in such case, normally if you dial, the call is connected and you will talk. But at the same time, what happens here is when your number is not reachable, or when you're talking to someone, an exception is raised, an abnormal situation has arisen, so exception is raised and it is handled. Same way, in case of Java also, if you are unable to open a file, if the memory is exhausted, or if you are unable to connect to some other, because in the case of networking, what you are going to do here is you are going to connect with other users also, another machines you are going to connect, because when you are using internet, what does it mean? You are just connecting to other machines. You are connecting to another machines there. In such a case, what happens here is some abnormal situations when they raise. So you need to handle such situations. So all those things are made mandatory in Java. You have to handle them. You have to handle them. Okay, the programmer has to handle them. Such abnormal situations. Second feature is about the object-oriented language. So Java supports encapsulation, inheritance, and polymorphism. So already we have discussed about what is encapsulation, inheritance, and polymorphism in the previous class. So it supports all the three important features of OOP. So Java is influenced by C and C++. It ignores all the ambiguous features of C++. There are some ambiguities in case of C++ regarding multiple inheritance, hybrid inheritance. So this default arguments, operator overloading. There are some ambiguities are there. So such ambiguities have been actually ignored by Java while developing. And it is Java is a pure object oriented. So C++ is not purely object oriented. So Java is a pure object oriented programming language. So everything in Java is an object. So you can have everything in Java which is considered an object, except some standard data types such as int and float. So you have some standard data types like int, float, some other data types which are used. Apart from this, everything is considered as an object here. So Java is an object-oriented programming language. Then you have the third feature is about Java is a dynamic language. Java is a dynamic language. So how you call Java is a dynamic language here? So a lot of activity takes place at runtime. Okay, during the execution time. So as you have learned in C, the dynamic memory allocation, where the memory is allocated dynamically. Here, in the while executing the program, a lot of activities have been has occurs in Java. The arrays are created dynamically. The objects are created dynamically. The arrays can be resized, reallocated at runtime. Means the size of the array while executing the program can be changed. It can be expanded. It can be shrinked in case of Java. And also the memory allocation is done by the Java, not by the programmer. So the dynamic memory allocation is done by the Java, not by the programmer. In the sense, see, we use the malloc function, calloc function. You are requesting in C for the allocation of memory. So how much memory is required, how much you are requesting the compiler to allocate the memory. But here, no need of any request or anything. Just you write the code and whatever is the required size of memory which is required. So it is automatically allocated by the compiler in Java. Okay, the arrays, the size of the array, the arrays are allocated dynamically. Okay, we will see practically how it is done very soon when we come across with one or two programs. Okay, one of some of the programs. Then the garbage collector is there. Garbage collector is actually the responsible for releasing the unused blocks in the memory. So you remember the free command after the malloc and calloc has been used. The last command which we generally use in case of C is after the allocation is f close and then we are saying free. Okay, so in dynamic it's here free p and free s means you have allocated the memory using malloc and calloc here. You have allocated s is equals to struct student malloc means you have allocated some memory here. After usage, you are freeing the memory. Okay, so this is also necessary in case of C. Means both allocation and deallocation can be done in by the should be handled by the programmer. But in case of Java, no need of that. There is a garbage collector which is going to collect the unused memory and adding it to the free space. So that's what we can do. So we have just deal which has just studied the introductory part of the Java and some of the features. So I would like to talk about the multi-threading, distributed platform independence. Okay, this all things in the next class. In the tomorrow's class, I just want to declare because they are going to take some time. So the next class we are going to spend on this. What is multi-threading? What is distributed nature? What is platform independency? Okay, all these things will be covered in the next class. So any doubt regarding today's class?
No, sir.
Anybody?
No, sir. No, sir.
No, sir.
No, sir. Explain the evolution of Java. Why Java has been evolved, right? That's what you are asking.
Yes, sir.
Yes. See, evolution. Why Java has been evolved means a lot of means people started using a lot of consumer applications. Means this electronic devices. People started using lot of this consumer electronic devices. So you know that electronic devices are containing this microprocessors. Today, most all the electronic devices having the microprocessor. So when they are having the microprocessor in the sense, they are executing some program. As you have learnt in CO, each microprocessor is having its own instruction set architecture. So what you have to do for every type of microprocessor, every type of instruction architecture, you have to write the program separately. Okay, program separate for every machine, every microprocessor. You have to write the program separate. So writing for 100 different types of microprocessor, 100 times different programs, maybe it would be difficult. For that reason, what they have done is they have developed an architectural neutral language, which is same for all the machines, which is same for each and every machine. So if machine A, B, C are there, three different machines, for all these three different machines also you are going to write the same program, right? So what that machines will have is they will have a JVM, which I will talk more about it tomorrow. So what the JVM is going to do is its responsibility is converting this uh, code into its native code and going to execute. Okay, so that's the reason why Java has become popular. Okay, that's the reason, because a lot of devices have came into existence, so they required an architectural neutral language. Okay, I hope it is clear, Nutana.
Yes, sir.
Okay, so you'll understand more about this tomorrow when I discuss about the JVM. I will give you an example there in tomorrow's class once again. So you'll have a better idea, you have a clear idea about it. Okay.
Okay, sir.
Okay. Okay, then thank you.